Exercise 10.3, we need to find the differential equation. Differential equation is simple exercise only, but we need to know the concept of the differential equation. So, if we are going to see dy by dx means we can write as y dash. Suppose d square y by dx square this is once differentiate, this is twice differentiate. D square y by dx square is nothing but we can write as y double dash. What is the meaning of y double dash? Y double dash is nothing but twice differentiate. If we are going to put y triple dash, this is called thrice differentiate. Y triple dash, this is nothing but thrice differentiate. Y triple dash is thrice differentiate. Dy by dx we can write as y dash, d square y by dx square is y double dash, and y triple dash is thrice differentiate, that is d cube y by dx cube. This is thrice differentiate. So this one you need to know in this exercise, then only can be easy for us. Next, you need to learn about the arbitrary constants. Arbitrary constants is nothing but the constant which will not change its value throughout the equation, throughout the sum. The constants which will not change its value throughout this sum. So first sum, find the differential equation. I need to find the differential equation. Non-vertical lines, they are speaking about the lines. They are speaking about line means we can say the line equation is nothing but y is equal to mx plus c. The line equation we know y is equal to mx plus c. This one you need to know, this m is a slope and c is y-intercept. Therefore m and c are arbitrary constant where m and c are arbitrary constant. So how many constant is present in this equation? Two constants, that is m is one constant, c is constant. If you are going to put value of x and y, this x and y only differs, not m and c will not changes. So the constant is nothing but m and c. This m and c arbitrary constants throughout the equation will not differ. Even though we are going to put values of x and y, this m and c is going to be constant. So how many arbitrary constants present here? Two arbitrary constants present here. The first sum is the important sum. Listen, because in first sum I am going to explain more things for you. So you need to listen more carefully. How many arbitrary constants present here? Two arbitrary constants present here. Since two arbitrary constants is present here, we need to differentiate two times. And the last equation, the last differential equation we are going to write, there should be no m and c. The arbitrary constant should not present in the last equation. That's in this sum, m and c is arbitrary constant. This m and c should not present in the last equation. This is the first condition. The arbitrary constant should not present in the last equation, that is the last differential equation. The arbitrary constant should not present in the equation. The second one, how many arbitrary constant is present? That much time you need to differentiate. Suppose here two arbitrary constant is present here, we need to differentiate two times. If only one arbitrary constant is present, we need to differentiate only once. Since we have two arbitrary constants, we need to differentiate two times. So differentiate two times. Differentiate of y is y dash. M is a constant. Differentiate of x is 1. C is a constant, so 0. Differentiate of constant is 0. So y dash is equal to m. M into 1 is m. Since two arbitrary constant is present, I need to differentiate once again. Differentiate of y dash is y double dash. Differentiate of y dash is y double dash. And differentiate of m is a constant, differentiate of m is 0. So here we can stop. Is the required differential equation. That's all. Sum is over. Is a required differential equation. Very easiest sum. If you are going to take second subdivision, the second subdivision is speaking about a non-horizontal lines. Non-horizontal line means we can take the same line. Y is equal to mx plus c, where m and c are arbitrary constant. Where m and c are arbitrary constant, here m should not equal to 0, because non-horizontal line m should not equal, that is slope should not equal to 0. That is m should not equal, non-horizontal line means it's a vertical line, should not 0. So this condition is must, m is not 0. The remaining you can write. Differentiate of y is y dash, m, differentiate of x is 1, differentiate of c is 0 because c is a constant. No, y dash is equal to m into 1 is 1. Since two arbitrary constants present here, I need to difference 2 times. Y dash difference is y double dash, m difference 0. That's all. Finish. Is the required differential equation. So from this we have finished the first sum with 2 subdivisions. Next we move to a second subdivision. Second sum, form the differential equation. I need to form a differential equation of all straight lines. We are speaking about straight lines touching the circle x square plus y square is equal to r square. Solution. Since x square plus y square equal to r square, here vertex is 0, 0. That is center. Center is nothing but 0, 0. Center is 0, 0. This is r square. Radius nothing but r. You can say radius is r. Radius is nothing but r. This we can say h, k. You know center formula x minus, if you are going to see the general formula for circle is nothing but x minus h the whole square plus y minus k the whole square is r square. Since h and k are 0, that is center is 0, 0, h and k is absent, so r square, r is nothing but radius. So are we going to draw this? This is x, y, x dash and y dash. This origin 0, 0, origin 0, 0. Find the differential equation of straight line. So I am going to draw a straight line which touches the circle at only one point. This is touching point circle. This is called tangent line. Since this line is called tangent line because it touches circle at only one point, it's a tangent line. So the circle equation nothing but x square plus y square is equal to r square. This is circle equation. What is the line equation? Y is equal to mx plus c. This is a line equation. Circle equation is x square plus y square is equal to r square, y is equal to mx plus c. I need to find the differential equation. Somewhat lengthy sum only, but don't need to worry. They given the equation. See, they given the equation x square plus y square equal to r square. So r is not a constant here because they given the equation for us. X square plus y square r square is the given equation for us. So r is not constant for us. R is not the arbitrary constant. So the given equation x square plus y square r square. Then we proceed the sum. So equation is x square plus y square is equal to r square, circle equation, and line equation y is equal to mx plus c. So apply y is equal to mx plus c in this here. So how I can form x square? You can apply x square in place of y mx plus c the whole square is equal to r square. But this process is lengthiest process. If we go into the sum, this sum will be a lengthiest sum. It becomes a lengthiest because after forming it will become a quadratic equation. After quadratic equation, you need to find the quadratic formula using x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Using this formula, we need to find the equation. After finding equation, you need to differentiate. The sum will be goes on as this. So I am going to do one simple method. So what is the method? Method is nothing but if you see the one formula, ellipse formula, y is equal to, listen very carefully, you know the one formula, if a line touches the ellipse, what is it? It became tangent line. Formula is nothing but y is equal to mx plus or minus square root of a square m square plus b square. This is a formula. Y is equal to mx plus or minus square root of a square m square plus b square. So here, since here this is a circle, this is ellipse 1. Circle is nothing but here a is equal to b. For circle, a and b are same. So y is equal to mx plus or minus square root of a square m square b square, we can add a square, but a is nothing but radius. No, here a is equal to r. So y is equal to mx plus or minus square root of r square m square plus r square. Y is equal to mx plus or minus r square is common. If we are going to take r square outside, we can put only 1r square root of m square plus 1. So using this equation, I can write. Therefore, what is the equation here? Y is equal to mx plus or minus r square root of m square plus 1. Using this only I am deriving this. Now we can do the differential. Here what is m is only the arbitrary constant, where m is arbitrary constant. Here m is only arbitrary constant. This very must, because r is not arbitrary constant, because r they given in the question itself. So r is not a constant, m is only the arbitrary constant. Now start to differentiate. Now start to differentiate. Y differentiate is y dash m. X differentiate is 1. This one has become 0 because m square differentiate is 0, no. So this is a constant, totally constant. R is also radius. Radius will be the first, but still it is not arbitrary constant. This R is a constant but not arbitrary constant. So differentiate of R is nothing but 0. Even differentiate of m square is also 0. So y dash is equal to m. Keep it as equation 2. So since I need to neglect, I need differentiate only once. Why? Because m is the only one arbitrary constant. We have only m is the only one arbitrary constant. We need differentiate only once. So I differentiate only once. But I need to neglect m since m is present. Two conditions to form the differential equation. What's the first condition? How much arbitrary constant present? That much time you need to differentiate. If only one arbitrary constant present, you need differentiate only once. If two arbitrary constant present, you need differentiate twice. If 3 is present, you need differentiate thrice. But only one arbitrary constant, I differentiate once. So what is the second condition? That we should neglect the last differential equation. We should neglect the arbitrary constant, but I not neglect here since it is present here. So to avoid arbitrary constant, I differentiate once but not avoided. So I am going to apply 2 in 1. How are you going to apply? Listen very carefully. What is m? M is nothing but y dash. So write y is equal to, what is m? Y dash x plus or minus r square root of m square plus 1. But see, what is m? I forgot this one. What is m? M is nothing but y dash square. Listen very carefully. M is y dash square plus 1. Let this one come this side. Y minus y dash x is equal to plus or minus r square root of y dash square plus 1. Y dash square plus 1. The sum is going to become very easy for you. Squaring on both sides. Y minus y dash x the whole square. If I am going to make plus or minus, this minus will become plus, this plus will become plus, so no problem. R square. If I am going to make square and square will cancel, nothing but y dash square plus 1. If you check the last answer, the both will be interchanged. So we can write y dash x minus y the whole square is equal to r square y dash square plus 1. Because a minus b the whole square we can write as b minus a the whole square. So no problem in this, both the answers. A minus b the whole square we can write as b minus a the whole square. Just interchange y dash x minus y the whole square is the required differential equation. See, there is no m, no arbitrary constant. This is the required equation. If there is another method also, this method will be lengthiest process. If you know this equation, then sum will be very easy for you. Thank you.